so if you're seeing my screen here, it says absolute value of x over x, but then it has a little semicolon. It says, hey, x is greater than 0. You have to know the following to be able to answer this question. It's x if x is greater than 0 and negative x if x is less than 0. So do you get a cheat sheet on your test or reference sheet or anything like that?
No, nothing.
Nothing. Okay, so you'll have to know this. I mean, it's pretty straightforward. Basically, it's x if x is positive, negative x if x is negative. And in this problem, you're going to replace that absolute value of x with just x, like that. What does that reduce to? What is x divided by x?
1.
It is 1. That's it. Now let's just say that it was like this, x less than 0. You would say negative x instead of x over x, which becomes negative 1, like that.
Okay.
Any questions, thoughts on that?
No.
All right. And if you need me to make up more problems like the ones we're looking at, you can let me know. Factoring will take some time, but these are fairly straightforward. This says the absolute value of 3 minus 3. I think this is formatted poorly. It probably should look more like where you're subtracting a negative 4 like that, and then you're multiplying everything times 5. You probably know by now that double negative becomes a positive.
Yeah.
So this is the absolute value of 3 minus 3. There's really like nested parentheses inside there, so you know to do that first, which is 0. So it's the absolute value of 0 plus 4 times 5. You can see that this part inside here becomes just 4. The absolute value of 0 is 0 plus 4 is 4 times 5 is 20.
Okay.
All right, so I'm looking at 31 through whatever. Let's see here. I'm going to do these out of order. That's okay, to sort of talk about the types of factoring that you will see. Maybe I'll do them out of order. I'm just kind of looking at them first to see if there's anything that jumps out. Hmm. Okay, I guess we'll do number 31 first. All right, so whenever you see even exponents and two terms, which is what you have here, you want to think difference of squares, like that.
Okay.
All right. You probably had some of these on the other side of the page. Difference of squares looks like this. If you have like a squared minus b squared, it becomes a minus b, a plus b, like that. And so this is, let me rewrite it here, x squared squared minus 1 squared, like that. The exponent to the exponent you multiply to get the 4. 1 to any power is always 1.
Okay.
So this x squared is like your a. Your a is whatever's being squared. Your b is whatever is being squared. So this becomes, maybe kind of write it off to the side here. I really like the way I've done this. This becomes x squared minus 1, x squared plus 1. Please
Okay.
let me know if this is unclear, because I don't know if I did a good job of explaining this, and it really matters if you understood it or not. A is the thing that's being squared. It's whatever's in parentheses. B is the other thing being squared in parentheses there.
Right. I get it.
Okay. All right. Now, there is no such thing as sum of squares, so we're done with the one on the right, but this one over here on the left is another difference of squares. So just like before, you could rewrite it. It's like, well, what is it that's being squared? Well, it's x that's being squared. It's 1 that's being squared. That becomes x minus 1, x plus 1. So the x squared minus 1 is replaced by this. X minus 1, x plus 1 times x squared plus 1 like that.
Okay.
This is a great kind of multiple choice thing. Lots of wrong answers. So
Yeah.
lots of ways to go wrong. Right. Any questions on that?
No, thank you.
All right. I'm going to go to 33 next because it's not the same as 31, but it's kind of in the same kind of trajectory. So the first type of factoring that you're always supposed to do is a greatest common factor or a GCF, which could be a
Right.
number or a letter uh, or variable. So notice that there's an 8 in both. Is that okay so far?
Yes.
All right, so this is now difference of cubes. There is both a sum and a difference of cubes. And this is just it's a pure definition. This becomes x minus y, x squared plus xy plus y squared. And I'll give you the one for sum of cubes in case you need to know this for your test. You'll notice it's very, very similar. The only difference is the signage here. So for your problem, and you know, again, you said you don't get a reference sheet, so you may want to ask if you need to know this. I'll probably tell you yes, unfortunately. But
Yeah.
it is all of this here. Let me grab this. That x cubed minus y cubed becomes everything on the right there with an x minus y like that.
Okay.
All right. Let's do 34 next. Excuse me, 34 next. We will get to 32. They're just as kind of an order for doing these in. This is
Yeah.
most students' favorite, easiest type of factoring. Call it A equals 1 type factoring. That A is referring to right there in front of the X. And so here you're looking for two numbers that multiply to minus 35, that's the last, but add a minus 2, that's the middle. And it's really a guess and check. It's like, you know your multiplications, or you have a calculator and you start, working out numbers that make this happen. Could you try coming up with those, please?
Um, -7 and 5.
Those definitely work. So this becomes x minus 7, x plus 5. Perfect.
Okay.
All right, so you got those down. All right, so the next grouping of problems starts with 32. This is a not equal to 1. So I call these a not equal to 1. These are grouping problems. They require a different approach. You end up having to take this first number and multiplying it by the last number, 4 times 6, 24. And now it's kind of the same as the last. You're trying to find two numbers that multiply to 24, but add to 11. You might even call this like a diamond method. I think sometimes they do that in the classroom. But I'd like you to come up with those two numbers that multiply to 24, but add to 11.
Okay. 3 and 8.
3 and 8. Okay, so you have a choice here. You either write 4x squared plus 8x plus 3x plus 6, or 4x squared plus 3x plus 8x plus 6. And you might wonder, well, why does it matter? You want to choose the one that kind of pairs best with the 4x squared. All right, so the top one is better because we're gonna find the GCF between these two.
Okay.
So what is the greatest common factor between 4x squared and 8x?
4x.
4x. 4x, and then inside parentheses here is x plus 2. You immediately write that over here to the right. And what you're looking for now is what goes in here such that when you multiply in the x plus 2, you get back to 3x plus 6.
Uh, 3.
3 plus 3. So this is a factor by grouping problem. We're using the grouping approach. It's really a double factoring because you end up factoring out the x plus 2 from both. See how these both have an x plus 2 in there?
Yeah.
And you can see where the 4x plus 3, they come down here like this.
Okay, right.
Have you seen this before?
Yes.
All right. The next problem here, 35, is similar, but it has an additional little wrinkles to it. First thing you'll notice about 35 is it's not in the right form. Like it's not in descending order. So it's good to rewrite it in descending order like this. Second thing is that you should always look for the GCF. So is there a number that goes into 48, 28, and 4? And that's kind of where you come in and you say, okay, you got to look for that. If you don't, it makes it much more difficult.
4.
4. So this becomes 12h squared minus 7h plus 1. Again, this is an a not equal to 1 problem because that a term is 12. All right. So we do the same thing with the previous problem. We take that 12 and 1. 12 times 1 is 12. And now we're looking for two numbers that multiply to 12 but add to -7.
Uh, uh,
They gotta both
negative
be
4
negative.
and
Yeah.
-3.
So which pairs better with 12h squared, -4 or -3?
Um, -4.
Okay. So we'll write 12h squared minus 4h minus 3h plus 1. And then we don't want to forget about this 4, but just kind of leave it kind of hanging off to the side here. What is the GCF between 12h squared and 4h?
4h.
4h. So this becomes 4h, 3h minus 1. And you put a 3h minus 1 immediately over here in parentheses. What goes in the middle here such that when you multiply in, you get back to the previous line?
neg negative one.
Negative one. So this becomes 4h minus 1 times 3h minus 1, like that. And then this is the time when you bring that GCF back down.
Okay. Okay.
So everything inside parentheses here is like the last one, where you're doing the grouping not equal to 1. The only difference was this 4 on the outside there.
Right. Okay.
All right, so 36 here. You always look for a GCF to start. Always, always, always. Makes it so much better.
6y.
6y. So tell me what goes in parentheses.
10y squared minus 3y minus 1.
Good. All right, so now again, it's an a not equal to 1. So you have to take that 10 and negative 1 and multiply them. 10 times negative 1 is negative 10. And you're looking for two numbers that multiply to negative 10, then add to negative 3.
2 and negative 5.
Yes. Now, which pairs better with 10y squared? And I don't think there's a right or wrong here, but is the 2 or is it the negative 5?
Uh, negative 5.
Negative 5y plus 2y minus 1. I didn't make this clear, but you probably saw this already. These two are how it goes back to the minus 3. That's the same in the others that we did. So now you factor out the GCF from the first two, just like we're doing all the problems. That's 5y becomes 2y minus 1. 2y minus 1 in parentheses. You always put whatever's in parentheses here, in parentheses off to the right. This time it is plus 1 because you don't need to make any changes to get back to the previous line. So it's 2y minus 1 times 5y plus 1. And then you do bring down this last little thing here, 6y.
Okay.
So if you understood those last few, you definitely understand how to do the grouping, factoring. It's the hardest one. Um, it's just a few more steps though. You've probably been doing this for a few classes now.
Yeah.
All right. I believe that is everything you sent over. Tell me if I'm wrong. Definitely don't want to miss anything.
That was it.
That was it. All right. Is there other things you would like us to look at tonight or anything else that I can help with?
Um, no, thank you.
All right. Well, we can absolutely stop here. It's up to you. We're, kind of halfway through the lesson. Is there anything else that you'd like to cover tonight?
I don't think so. No, thank you.
Okay. I'm going to go ahead and stop the recording.